All right, so this is the last one on here. It's the one that is associated with the Kodiak Grizzly bear. It's friendly. We're not trying to kill the bear. We're just trying to get close enough to the bear for a selfie, for social media. Like, Mr. Bear, I'm going to put my head in your mouth, and don't bite down, but it'll make a good photo if my head's in your mouth, okay? So we want to tame the bear long enough to make a photo. I hope the first step that everyone did was draw a line down the middle. I hope that's the first step that everyone did. Okay. Now, walking around, most people started on the left-hand side. Most people started on the left-hand side. And what most people did is they multiplied by the conjugate over the conjugate. So let's explore that. Okay? I'm going to take a whole separate line here, and the conjugate of the denominator in the first is 1 plus cotangent of x over 1 plus cotangent of x. And of course, that's times tangent of x over 1 minus cotangent of x. That's what was there. Plus, the conjugate of the next one would be 1 plus tangent of x over 1 plus tangent of x times what was there, cotangent of x over 1 minus tangent of x. So that's a total legal move. Now we're going to see if that pays dividends. The whole reason we do that is so in the denominator we get 1 minus cotangent squared of x, and in the next denominator we get 1 minus tangent squared of x. Now in the top, did y'all distribute in the top? Yeah, I would too. At this point, I would distribute in the top because if you kind of notice what's going to happen, you get tangent of x plus what? 1, because cotangent and tangent are what's with each other? They're also cofunctions, but in this case, they're 1 when they multiply them because they're reciprocals. Yeah. And same thing over here. If I distribute the cotangent, I get cotangent of x plus 1. So that seems like it's a real nifty thing to do, right? So we compare that to the left-hand side, which is our target, or the right-hand side, sorry, which is our target, and we go, Now, in the denominators, you might be thinking Pythagorean substitution, right? Because that's typically what happens when you multiply by the conjugate over conjugate. You set up a difference of squares, which is the baby pids. Let's write the baby pids over here. 1 plus tangent squared of x is equal to secant squared of x, and 1 plus cotangent squared of x is equal to cosecant squared of x. So what do I have in my denominator? I have a 1 minus cotangent squared. Can I call that cosecant squared?
You can call it negative.
Could I call it negative cosecant squared? Are you sure? If I multiply both sides by negative, I get negative 1 minus cotangent squared is negative cosecant squared. Do I have negative 1 minus cotangent squared? No, I have what? 1 minus cotangent squared. Guess what 1 minus cotangent squared is? It's nothing. It's 1 minus cotangent squared. Ruh-roh. What about 1 minus tangent squared? Same exact thing. I can't replace it with a single trig function. Pooper, scooper. What about the top? Tangent x plus 1, is that equal to secant? No, it's not squared, is it? So it doesn't work. Sorry, Ray. I was hopeful too. So what do we do from this step? Yeah, if you wanted to keep going down this vein, you could say, okay, now I'm stuck. I'm going to put it in terms of sine and cosine. But if you're going to put it in terms of sine and cosine, maybe you should retreat back to the beginning and do that, right? Because notice it's a little more complicated now. You have squared instead of non-squared, and you have plus 1s in the top. So here's what I'm going to do. I'm just going to take this, and I'm going to bring it over here, and I'm going to put it in a storage closet. It's not wrong, but it's not the direction I think I want to go at this point. Okay? Poop. Did anybody do anything different on the left-hand side? Tell me, Jeremy. You got a common denominator. Okay. What's the common denominator of 1 minus cotangent, 1 minus tangent? Them multiplied together. We call it their product. Let's try that. So I'm going to have to multiply the first one by 1 minus tangent over 1 minus tangent times what was there, tangent of x over 1 minus cotangent of x. Plus, I have a 1 minus tangent. I need to multiply it by a 1 minus cotangent. 1 minus cotangent of x. All times what was already there, cotangent of x times 1 minus tangent of x. Okay, so that should give me a common denominator. Now, in the denominator, I get 1 minus tangent of x times 1 minus cotangent of x. Now, Jeremy, would you distribute the tangent inside there and the cotangent inside here? Would you do that?
Yes.
You would? Okay, so you get tangent of x minus tangent squared of x plus cotangent of x minus cotangent squared of x. What else, Jeremy? What did you do this right? What did you do next? Oh, what did you do from here then? You multiplied out the denominator too? Okay. Is there anything else you did in the numerator once you expanded here? Okay, so I'm going to cheat and I'm just going to copy this because it is a lot of writing. I'm just going to copy that. And maybe I could have distributed the denominator as I wrote it down, but remember, when in doubt, don't leave it out, show the steps. So if I follow the denominator, I get 1 minus cotangent of x minus tangent of x, and then I get plus 1, right? Tangent times cotangent is 1, and the negative times negative is a positive. Ooh, 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 ooh. I see something else I can do in the denominator. So let me copy this, paste it. What's 1 plus 1?
2.
I can call that 2. Yeah, buddy. Yeah, buddy. I'm cruising now. You compare it to the right-hand side, and how's it looking?
Really far away.
Gulp. Big gulp. Yeah. What'd you do from here, Jeremy? Anything? What? Go ahead. Oh, do these divide out? Do these divide out? Oh my gosh, you're killing me.
Negatives.
Why do they not divide out? Those are what? We can only divide out common what's? Factors. Factors are multiplied or divided. Those are terms. Those are being added and subtracted. Can we divide out terms? No. 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 We can't. That was a nice try, though. So what will we do from this step? Oh, how? Well, do you see a common factor? We got 4 terms on the top. If I factor the top, it'll look just like this up here. It'll be tangent times 1 minus tangent, cotangent times 1 minus. It would be partially factored. I can't factor the whole thing. Guess what? I'm going to have to rent another storage unit. I'm going to have to rent another storage unit.
No wonder we're going to need the whole class period.
Yeah. You know what someone last period did? They did this. They did tangent of x all over 1 minus 1 over tangent of x plus cotangent of x over 1 minus 1 over cotangent of x. And I asked that fellow why he did that, and he said, so I could get each term in terms of a single trig function. And I was like, hey, that's not bad. That's not bad. Now I have a complex fraction at least, right? And when we have a complex fraction, we rejoice because the very next step is to get rid of the complex fraction. So this one I would multiply by cotangent of x over cotangent of x. And this one I would multiply by tangent of x over tangent of x. And if I multiply straight across, I get tangent squared of x all over tangent of x minus 1 plus cotangent squared of x all over cotangent of x minus 1. And that looks kind of better. Is it?
Why did it not pop Now we can use a baby
Are you? Oh, why did he call? Why did he move? Why did he do this step?
Oh, no, not that step.
Oh, the next step. If you distribute the tangent, Oh.
Like turning this into 1
Oh, for the same reason. He wanted to get these to be the same trig function. The tangent is 1 over cotangent, and cotangent is 1 over the tangent. So he was trying to get each term in terms of a single trig function. That was just his idea.
over.
Okay?
Didn't we do the products thing like last time?
Products? What do you mean?
Hold on.
At this point, I asked that fellow what he could do, and he said, "Hey, can we call tangent squared secant squared of x minus 1?" I said, "Yes, we can. That's baby fid number 1. And then we can call that secant of x minus 1 times secant of x plus 1, all over tangent of x minus 1. And I was like, yes, we can. We can still do that. But you know what? The whole point of doing that is to maybe divide something out. Does anything divide out after we do that? No. So guess what I told that fella?
We're done.
I said, fella, that's not illegal. But you know what? It's going to take us further away from where we want to go. So we had to rent another storage unit.
Back to the
Hey, that's not a bad idea. That's what came up next. Someone said, Mr. Korpi, what if we just jump to the other side? And I was like, okay. So when I jumped to the other side, I got secant times cosecant. And remember, this is one of your strategies. If you have a product or a quotient of two trig functions, and you want to see how it simplifies down, put everything in terms of sine and cosine. So that should be your next cause, is to put everything on the right in terms of sine and cosine. That gives you 1 over cosine times 1 over sine, which gives you 1 plus cosine x sine of x. Okay, so nothing simplified. Nothing simplified. But now, and here's your next line of thought. Now, since the right side is in terms of sine and cosine, wouldn't it be helpful to put the left in terms of sine and cosine? So now we're just comparing apples and oranges to each other instead of all the fruits, right? So let's try it. Let's now put the left side in terms of sine and cosine. See what happens. So we're going to have sine of x over cosine of x all over 1 minus cotangent, which is cosine x over sine of x. Plus, leave a little space in front. We're going to have cosine of x all over sine of x all over 1 minus sine of x over cosine of x. And now you should rejoice on the right-hand side because we created a complex fraction. And anytime we create a complex fraction, the reason we get happy is because the next step is obvious. We have to eradicate the complex fraction. And we can't do state change flip here because there's two terms. But we can do lick 'em over lick 'em, right? So what is the LCM of your miniature denominators in the first term? We got a cosine and a sine. What's their LCM? Their product, sine x times cosine x. Sine x, cosine x. So I got to multiply by sine x cosine x, sine x cosine x. Same thing in the second one. My two miniature denominators are sine and cosine. So I'll multiply by sine x cosine x over sine x cosine x. And now I multiply straight across. And if you do that, notice in the top apartment, your cosines divide out, and you're just left with sine squared. And in the bottom, I would distribute to get rid of the complex fraction, and I get sine x cosine x times 1, which is just sine x cosine x. And now the sines divide out, so I get cosine squared of x. So there's your first term. We killed the bunk beds. The next term, very, very similarly here, the sines are going to divide out, and you get cosine squared of x. All over distributing, you get sine x cosine x, minus the cosines divide out sine squared. And now you compare that to the right-hand side, and you're like, yeah, we're getting closer. We're getting closer. We have two terms, and it's all in terms of sine and cosine. Now what? Oh, boy. Hey, I see sine squared plus cosine squared in the left. See that? Can I call that 1? Why not, Jeremy? I can't. Because the denominators are what? Different. Oh, they're different. They're almost the same, but they're different. So I can't call that 1. But what do you notice about the denominators now? Is there anything we could do in the denominators? We could call cosine squared 1 minus sine squared, but that's going to get us 3 terms because the 1's going to be the third term, and we're not going to be able to combine anything.
So we can't do that in the top.
Oh, we can call yeah. Let's think about that. We can call the top 1 minus cosine squared, and that would make that would then on the next line say that it factors into 1 minus cosine times 1